Welcome to the final single-part tutorial. Today, we focus on the fastening bracket, a sheet metal bending part that introduces us to new methods and functions. After creating prismatic and rotationally symmetrical components in previous tutorials, we now turn to designing a sheet metal bending part. In this video, you will learn about two different methods for creating such a component. You will find out how to generate a flat pattern, export a DXF file, and adjust the sheet metal rules to your requirements. With these techniques, you will gain the basics to design sheet metal parts precisely and prepare them for manufacturing. Let's get started and create the mounting bracket together. Let's start with the first method to construct our mounting bracket as a sheet metal part. For this, we first switch to the sheet metal workspace. We start on the XZ plane with a new sketch. Here, we first draw the inner contour as a single line. Now add all measurements and dependencies so that the sketch is fully defined. In the next step, we will create a flange from this sketch. To do this, select the flange command under Create. Mark the entire sketch to create the sheet metal contour of our mounting bracket. Now set the distance to 35 mm and ensure that steel is selected. The sheet metal rule ensures that all material parameters such as thickness and bending properties are automatically adopted. The thickness of the sheet metal is defined by the sheet metal rule, which we need to adjust shortly. Before confirming, check if the sheet thickness is being applied in the correct direction. Since we have drawn the inner line of the contour, everything should fit. If you had drawn a center line or outer contour, you could adjust the orientation. Now we should adjust our sheet metal rule. Under the Change menu, you will find the sheet metal rules where we can set all the relevant parameters for our material. This is particularly important to optimally align the component with the manufacturing requirements. Here, you have the option to use an existing rule from the library, adjust it, or create a completely new rule. In our case, we are adjusting the steel rule. For this, we right-click on Steel and select Edit Rule. For the material thickness, we select 2 mm. We leave all other settings unchanged. Once the rule is edited, we save it. Since we previously selected steel for our component, the change is directly applied to the component. Now, we want to learn an alternative method to construct the basic structure of our mounting bracket. This time, we first create the upper surface of the bracket, and then add the two side flanges. To try this method, we first suppress the previously created flange in the construction history to make room for the new construction. Then we start with a new sketch on the XY plane. Draw a rectangle with dimensions of 24 by 35 mm in the sketch. In the next step, we use the flange tool to create the top surface of the mounting bracket from the sketch. Once this flange is created, we give the component its characteristic curved shape. For this, we use the flange tool again and select the two lower long edges of the sheet. Enter a height of 16 mm for the flange. You can see that the two side bends of the mounting bracket are added, and the component is gradually taking its final shape. With this method, it is also crucial to select the right reference settings. Since we focus on the inner lines of the mounting bracket, we set the height reference point to the inner surfaces and the bending options to the outside. Additionally, at this point, we could also specify a bending angle other than 90 degrees. To quickly and easily check if we have made the correct settings, we click on one of the inner surfaces. The area is now displayed at the bottom right. If we additionally select the opposite surface, the distance between them is displayed. This function is useful for quickly checking measurements. In the same way, many other details can be measured, such as edge lengths, radii, angles, or similar things. Finally, we need to add the two flanges that will later be used for mounting on the base plate. Use the flange command again and enter a measurement of 12 millimeters. Here, we need to refer to the outer surfaces and use the bend option inner. If you are unsure whether you have set everything up correctly, you can check the dimensions of the component with the measuring tool and compare them with the drawing. Now only the cutout and the drillings are missing. For that, we simply place a sketch to the side, trace the cutout and extrude it as a cut. The fillets will be done as usual. You can position the drill holes as you see fit, either using a sketch or directly with the drilling function and an arrangement. Since it is a sheet metal part, we should now create the flat pattern. For that, go to Create and select Create Flat Pattern. Then choose the top side as the stationary face. Now, we see the flat pattern with drawn bend lines. We can also export the whole thing as a DXF. The export function is displayed directly in the toolbar. You can store the DXF file either in the cloud or locally on your computer. To exit this view, we simply click Finish in the toolbar. You can return to this view at any time by activating it in the browser. Don't forget to save your component. In this video, you learned to create sheet metal parts in two ways. First, you drew the contour and converted it directly into a sheet. Then you created the component by bending it step by step. Additionally, you learned to adjust sheet metal rules. Congratulations! You have successfully created all the components. In the next video, we will assemble the assembly.